Mick McQuaid here with part 3 of chapter 1 of our textbook, R for Data Science. Previously we've gone through aesthetic mappings and facets, so in this part 3 we'll talk about geometric objects, and then we'll continue on in the next segment with statistical transformations, then position adjustments, then coordinate systems. And that'll be it for chapter 1 of this fine textbook. So the section starts out with, I think, a misprint. So the section starts out with these two plots, and I don't think that it intends to start out with these two plots. I think instead it intends to start out with these two plots. So let's take a look at them. Let's run this code which appears in the book. So the left plot should be this, and the right plot should be this. And so these two plots cover the same data, but they use different geoms, geom point and geom smooth. So we use different geoms to get different representations of the data. Now, here's the actual code as it appears in the book, and here's another example of how we might code differently. So we can code in geom smooth for line type, and we get this result. So we get one smooth line for each of the drive types, and the gray area around the line represents standard error, which we're going to be asked about later. So that's one standard deviation each way from the estimate. Let's see, the text continues and shows us an example of putting two geoms. We're getting a little ahead of ourselves here. It shows an example of putting two geoms on the same. Oh, before I say that, I should go over this one. So notice this is the one that we just did. So look at this one. And we get essentially the same thing, except that there's no legend. And the line types are the same. But we've grouped the geom by drive types. Okay, going on to this example from the bottom of page 17, here's one way that it could have been done. He doesn't actually show the code for this one, but here's one way that it could be done. So what you see here is we have geom point plus geom smooth. Then on page 18, he mentions a couple of, or I should say they mention a couple of URLs that are worth knowing about, particularly this RStudio cheat sheets. I've already shown you this cheat sheet. This is a good summary of the capabilities of ggplot2, so you should use it. Then at the bottom, it shows a triplet of graphics. So let's look at those. Oops, wrong window. There we go. So there's one. There's two. And there's three. And notice that we've used show legend equals false here. And I think that's probably just so that we can fit all three of these across here. And the legend would only apply to this one anyway. Okay, and so then here's an example of adding multiple geoms in one plot. So we've seen this before. And here's the same thing, but with global mappings. So what we've done here is duplicate this code. The mapping code has gone in each geom. And what we're going to do here is put the mapping code in a global space that will be inherited by these two. So we'll get the same plot. So we get the same result. Now we can also, they point out, extend or overwrite mappings for individual geoms. So here's one that has the same mapping globally, but it has an additional mapping for the point geom. So we get this in color, but we don't get any color, not that we would necessarily want any color on the smoother. And we could specify a subset in one geom and the whole data set in another geom. So that's what we're going to do here. So the geom point is the whole data set, and then in geom smooth we're going to filter by class, and we're only going to show a smoother for the subcompact class, not to give the whole thing away. So you can see that the smoother only goes part of the way through the plot, because the subcompacts only go part way through displacement. In other words, there are no there are no 7 liter subcompacts. Okay, and then we have some exercises. So let's see what the exercises have to say. What geom would you use to draw a line chart, a box plot, a histogram, an area chart? And in all of these cases, I would just look up the cheat sheet, and we would see, let's see, a line chart is over here, geom line. For a box plot, here's box plot, geom box plot. For a histogram, we have geom histogram down here. And for an area chart, we have geom area right here. So pretty much all of these are geom followed by the name. Geom line, geom box plot, geom histogram, and geom area. We have seen, I think it was in a previous video, we talked about the fact that you don't need geom histogram, that it can be obtained in other ways. Geom histogram is actually a convenience function in a sense. Okay, then run this code in your head and predict what the output will look like. Then run the code in R and check your predictions. So let's first look at the top part. So here are some global mappings. We've got color map to drive type, and we've got this same displacement highway that we've been looking at. And then we add to that geom point. So what is that layer going to look like? Then we're going to add geom smooth without the standard error. So it should look like basically like this, except that it'll go all the way through. But we've got color equals drive here, so we actually should get 3 of these lines, 1 for each drive type. So it'll look basically like this. Well, let's actually look at it. Is that this number 2? Yeah. And yes, indeed, that's what we got, colored dots and the 3 colored smoothers. Okay, what does show legend equals false do? Well, it removes this legend. What happens if you remove it? Why do you think I used it earlier in the chapter? So we used it, let's see, we used it, what is this, number 3? We used it on here. And it removes the legend. Let's do it without show legend false. I'll just comment that out and rerun this. And we get the legend. So why did we do it earlier? It was just, I think, so that the triplet would fit easily. Okay, number 4, what does the SE argument to geom smooth do? It provides the standard error grayscale, but let's look at the geom smooth to see that. So you'll see somewhere down here, SE display confidence interval around smooth. and that confidence interval, I believe, is just one. Well, maybe it's not. No, it's got to be standard error. Otherwise, why would it even be called SE? So the confidence interval is, I think, one standard deviation around the estimate. Okay, so one standard deviation each way around the estimate. Okay, so number 5, what is number 5? Well, these two graphs look different. Why or why not? So the first graph has got global mappings. The second graph has got individual mappings in the geoms, but the individual mappings look the same to me, so I'm going to guess that they'll look the same. I don't really see any difference here. Okay, so we've got that. I think this is just something that we saw earlier. And we've got that. So yeah, I think they look the same. And the reason why is because we've simply got the same mappings globally here that we have locally here. Okay, number 6. This one is actually a little bit challenging to me. So I actually didn't get one of them. So if you have a little trouble with these, don't feel alone. Okay, so here is the first one. That one's pretty easy. We're just doing the point geom and the smooth geom without the standard error bar. And the second one is the same thing, except that we're going to group by DRV. Oh, I think I messed this up. Let's see what. So that's funny. So I said group DRV, and that worked for the bars. So actually, I'm kind of surprised that this worked. This doesn't look right to me. It seems to me that I should have put group equals DRV in geom smooth, as a mapping in geom smooth. Okay, then the next one is in living color. So I need, what do I need here? So I've got the group, blah, 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 colored equals DRV for both of them. So this looks right to me. And yes, this is right. And there's more than one way to do these. You don't have to do them the way that I've done them. Here's with one smoother. So I've got color equals DRV locally in the geom point, and I don't have anything in the geom smooth. So that should be right. Then I've got a slightly more elaborate one. So this one is when I use line type previously, you may recall. Huh, no, that's not right. Is it right? Oh yeah, it is right. Okay, never mind, that's correct. Okay, and then this last one I couldn't figure out. It seemed to me that it should be done some way with using stroke, but every time I used stroke, it colored in the individual dots as well. So somehow I don't know how to use stroke correctly. So I cribbed this from Jeffrey Arnold's fine online solutions, which is basically to just do two geom points overlaying each other. So if you look carefully, you'll see, well, actually those sizes aren't that great, are they? Maybe I should go 4 and 5. Oh, I know what I'll just do fill equals white. Yeah, okay. So that actually works, but it's not satisfactory to me. Well, I should have been able to do this in one. So I should have been able to apply these stroke things, I think, and a stroke color, but not a stroke fill. So that's what I tried, and it was unsuccessful. I also tried putting fill in DRV and stroke down here, but that didn't work. So this isn't even my final, I guess my final solution is this. And that's sort of an okay solution. Okay, so that's it for geometric objects, and that's it for this video. So thank you for your attention, and I look forward to doing stats or statistical transformations next.